Welcome back. Now we're going to show you guys at home in class how to multiply using the area model. Okay, so first thing I'm going to do is I'm going to draw a box. The box is a square, and as always, my drawings are not perfect, or far from perfect. So just use your imagination with me to pretend that everything is equal. So the two sides to our square are going to be 2 meters. Now the first thing we can do before we start getting into breaking into fractions is to talk about just area in general, guys. So to find the area of a square, area equals length times width. Everyone see that? Who can tell me what area, how to find area? What's the equation? Stinson.
You have to do the length times the width.
So what two numbers are we going to multiply here to find the area of the square, Eric?
2.
Yep, 2 and 2. So for the area of this square, you're going to do 2 meters times 2 meters. And who can tell me what that is, Tabitha? 4. 4 meters what? When we find area, you got to label your answer. When we're finding area, you also have to add something else to the unit. Nope. No one has guessed? Squared units. When you're finding area, your answer is always in squared units. You can show that by putting an exponent of 2, right? So, this square has an area of 4 meters squared. So that's what we want to start off with here, okay? Everyone with me so far?
Yeah.
All right, so let's pretend that this is the classroom, okay? Obviously, the sizes are way off. 2 meters is not very big. But let's just pretend. Now, my area, my desk is just one corner. This is the area of the classroom that I use. Okay? Everyone see that?
Yeah.
So our goal of this activity is to figure out what is the area of this square. This little corner. What is the area? Well, we know the whole area is 4 meters squared of the whole shape. So we are trying to figure out what is that little square in the corner up there. Okay? So here's how we do this. Well, I should also tell you, the questions will give you the fractions. So we're going to say it's 2/5 vertically. And how about 1/3 sideways? So it's 2/5 of the room vertically. That's what that fraction's saying. It's saying this from here to here is 2/5 of the whole size of this whole side length. And then it's saying that from here to here is 1/3 horizontal. Okay? So now that we have our fractions, we need to split the whole box. I always make a brand new box here. So I'm going to go over here. So here's our classroom again. And here's our fractions, 2/5 and 1/3. Now guys, this is a little bit of review. Okay? What can we do with these fractions? What do these fractions tell us? What's our next step here? We already did this once. We're making the area model. What do we have to do? Tabitha, you know? Sinsa?
What was the question again?
What's our next step here? We have our fractions, one up top, one on the side. What's our next step?
To put the meters.
No, not quite. Kara? We're not adding the fractions. We got to make a model first. How do we do that?
We have to, you have to write a multiplication, like a multiplication problem.
Nope, one more try and then I'll tell you. Aaron?
You gotta draw a line.
So, yes, we got to split them. We got to draw bars vertically and horizontally. Because what we're doing is we're splitting this into smaller sections, right? We got 2 fractions. We got to try to split them into smaller sections. So, how many columns do we make and how do we know? Our fractions up top. How many columns do we make and how do we know? Aaron?
Okay, so going down, you make 3 shapes.
So stop right there. You make 3 columns, just like this. How did you know to make 3 columns, Aaron? The top fraction is 1/3. The denominator tells us how many columns to make. Now let's go to the side fractions, 2/5. Okay? So Aaron, how many times are we going to split it horizontally?
5.
5 times, so there should be 5 rows.
1, 2, 3.
And in a perfect world, they're even, right? But we're not in the perfect world right now. So let's go back to the top. All right? Go back to the top. Who has a guess? How many do you think we shade in, and how do you know? Jaden. Shh. I can't, guys. I can't hear. Not 3.
I think we shaded, I'm guessing that we shaded 1.
You shade in 1 because the numerator's 1. So 1 out of these 3 vertical columns is going to get shaded in all the way down.
And then,
Just like that. Stop right there, sir. Let's move to the horizontal, to the rows. How many of these rows do we shade in? Macasia? 2. Numerator's 2, so we shade in 2 all the way. See that? Okay? Now, what I do next is I box in the squares that have both colors that are overlapping. So these 2 squares, it's hard to see probably at home. These 2 squares are overlapping with the purple and the black. So there's 2. So what this tells us, guys, is that the numerator is 2 of our answer. So we got 2. Now to find the denominator, we got to figure out how many total little boxes there are. How many times did we really split it up? So you can do it like this. You can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Or, and this helps for bigger numbers, or you can just multiply the 2 denominators, 5 and 3, you get 15. So you get 2 15s. So pretty much what we did right there is we used a model to do 2/5 times 1/3. So we just visually showed you what that looks like in a model. And parents at home, I get it. This, to me personally, is a lot easier to do. I get it. But unfortunately, like I say in all my other videos, the powers above tell us we got to try it like this. And the reason we try it like that is for maybe more difficult numbers. So instead of working with 2 and 2, maybe it's 58 and 79. And our students maybe are struggling with multiplication of numbers that high. So that's where this might come in handy. But I'm going to show you this way anyway. So you get 2 15ths. So we know, I'm going to erase that question mark. Do I you back on this square with me, buddy? We know now that this square is 2 15ths of the total square. So if we're trying to find the area of this square, this isn't our answer. No. This just tells us that this little piece right here is 2 15ths of the total square. Well, what we do know though is we do know what the area of the total square was. What was the area of the total square, Tabitha? 4 meters squared. Say squared. Everyone say 4 meters squared.
4 meters squared.
4 meters squared. So what this is, to find the area, this is 2 15ths of 4. So if I write this out, and we talked about this too, 2 15ths of 4. First of all, what kind of a math problem is this? Remember when I talked to you guys, I said, when you're dealing with fractions, if you see a fraction of a number, what does that mean? What kind of math problem does that represent, Eric? Multiplication. This of can be replaced with the multiplication sign. Just like that. And now we got a fraction times a whole number. What do we put below a whole number to make it a fraction, Aaron? Eric? Not 4/4. So 4/4 would make it equal to 1. But we want it still to be worth 4. A 1. So Eric, that was a good guess, but if we put 4/4, that would make it 1, right? Right, and we don't want to do that. We still want it to be equal to 4, but we just want something to hold our place there so it's not confusing. So now, when you're multiplying fractions, you multiply straight across, just like the arrows show us.
2 times 4.
See the arrows? So 2 times 4, we're running out of room. They're right down here, guys. 2 times 4 is, class?
8.
8 over 15 times 1 is?
15.
So, this little square right here is 2 15ths of the whole, but if we're going to make that a total, a number of meters, it is 8 15ths of a meter squared. And that's how you find the area of just a subsection. Okay? All right, go ahead and cut it.